Welcome to this third video on how to recreate asteroids in Unity. In this video, I'm going to show you the workflow on how to bring your own scripts, how to create your own scripts in Unity, some of the basics of scripting in Unity, and where to find the reference for adding a lot more functionality to your scripts, how to dive deeper into the guts of Unity through your scripts. In this particular lesson, again, we're not looking at the asteroid game, as you can tell. I figured it's going to be easier to demonstrate some of these things without with something to look at rather than just black empty space. So with this more tangible little level here, let me show you what I have, and then I'll describe what it is I'm going to create as an example. So hitting the play button and using the scripts from the previous video, from video number 2, I create this simple little level with this cannon thing right here that I'm standing underneath, and there's this ramp right here that I'm going to need to use to get up to the second level. And as soon as the player, try to use the ramp, then, oh, the cannon fires over my head. Little warning shot. Well, that's all fine and everything, except, hey, it was really easy for me to get up here. What I'd rather have instead is, rather than just a single warning shot, I'd like that thing to fire over and over and over all the time I'm trying to get up that ramp, which means that maybe part of the gameplay might be to find a shield or to disable the cannon or something like that first. None of that functionality exists at this point. What I'm wanting to do for this video is just to show you how to create a little bit of extra functionality, and whenever you need to do something unique for your game that you don't have, this is an example of doing something like that. So again, in this case, I want to write a script that lets that cannon fire over and over and over until the player exits this trigger volume that I have set up on this ramp. Let's start that process. So I'm going to stop the game from playing, and just to familiarize you with a little bit of what I have going on here, there's the player character that I have the player script on from the previous video. There is a cannon trigger, so let's use this whole screen. So can you see the green outline here? Okay, that's the trigger. If the player steps in this trigger, which you'll notice over here, here's the script, on collision, send message. And what we're doing is on trigger, and you notice the is trigger checkbox is checked, so this thing is now a trigger rather than a collider. It's going to send the message fire to the object cannon. See over here, when I clicked on this, the cannon object is what we have, is what this thing is what on collision send message is going to send the message to. Let's click on the cannon, take a look at it for just a quick second. On the cannon we have this other script, which is the on message create object script. So whenever this cannon receives the message fire, right here, whenever it receives the message fire, then it's going to create this object, which, if you look over here, it's a prefab thing that I drug. All it is a white ball I guess I'll drag this out here so you can take a look at it. It's a white ball. Oh, where did it go? Okay, well, no, oh yeah, that's right, I made it a red ball. It was white at one point. So it's this red ball that whenever it is created, it has a script on it itself that when it hits something, it'll destroy itself. And it's got the missile controller from the Asteroids game. And all that does is move the object in the Z direction for this length of time, and then it kills itself if it hasn't hit anything yet. So that's all that is. We want to spawn a bunch of those things at the origin of the cannon, anytime the cannon receives the message fire, it creates one of these things right where it is. Okay, so let me delete that from the scene because we don't want it flying around the scene at the very beginning for no reason at all, because that's what it would do. It would just take off. All right, so here's our scene. I'm going to go over here into the JavaScript folder where our JavaScripts live. Let's create our script. Right-click in this scene. Go up to the Create option in the pop-up menu. Go to where it says JavaScript. I click on this and notice that right away it's created a new object, new JavaScript. You can tell by the icon. And it's ready for me to type in whatever the name of this new thing is that I created, whatever I want to call it. So I'm going to call it onMessage, onMessage send timed message. And I'm calling all my JavaScripts, or adding a JS to the end of all the JavaScripts so we can tell them apart from the Unity scripts, from the C# scripts. Okay. So there it is. I've created it. Notice that whenever the inspector over here, just like when you have some object in the hierarchy selected, it shows you properties of that object. Well, if you have a script selected, let's look over here in the inspector, it shows us what is in that script. And cool enough, whenever we create this script, instead of being just an empty blank file with nothing in it, Unity stubbed in two of the basic things that we need to have a script operate for Unity. And there's no editing for this, it's just a viewer just showing us what's in there. To edit any script, all you have to do is double click on that script, and then Unity goes and fires up the Mono Develop editor and shows us here's all the other scripts in our Unity project, all the other JavaScripts in our Unity project, and loads in the editor part of the window that script. A little bit about Unity script. There are two functions that it creates by default. The start function is executed automatically once by Unity. So whenever you drag this script onto some object, whatever code you put inside this function called start gets executed right as the game starts up. If the object is enabled right when the game starts up, one of the very first things it does is execute whatever code you have in here. So like maybe you want to set some variable to a particular value before the game starts. This is where you would do that. This other function called update. This update function gets called over and over and over again throughout your game. Every single frame of the game, this update function gets called. So if you want to, so whatever this object does over and over and over again, like maybe move, maybe rotate, whatever it does in your game, this is where you put the code if it needed to update every single frame, which most things tend to need to do. If you look through these, through some of these guys, like the blink, every single whatever it's doing, it happens typically in the update function here, because that's what Unity calls to have our script operate. There are other things, but for now we're just going to stick with these two. So let's get to work here a little bit. You've noticed in some of the other scripts that we have inputs, like in the inspector, we have things we can customize, like what object is it going to send a message to. The way we describe those, the way we define those is above the functions. we go ahead and define those variables here. And there are two basic kinds of variables, public and private. Public variables are displayed in the inspector for the user of the script to be able to edit, to put whatever adjustments might need to be made for this particular object, whatever details, other objects this script might need to know about. Those kinds of variables get defined here and are called public variables. So we type public, saying this is everybody, this is going to show up in the inspector window. And for Unity script, or for JavaScript, and that's I keep saying that because typically Unity calls what we're editing this, Unity says it uses JavaScript, when in fact it would be more precise to call this Unity script, which actually most people in the Unity development community do reference it as Unity script, just to not confuse ourselves, because this is close to JavaScript, but it's not JavaScript. It's sort of a hybrid between JavaScript and C#. But at any rate, this is Unity's version of JavaScript. So public, the keyword variable, saying we're creating a variable, and I'm going to call this variable timer on message. And to declare this as a particular kind of variable, type, I want it, JavaScript in Unity, if you type the variables, then they execute faster. And we like faster because we want to make our games as fast as possible. If we just go ahead and type it and tell it what kind of variable it is, then we gain that extra speed. So I want this to be a string because we want to, our message is going to be a string of some kind. And then we say maybe what the default of this variable is going to be before anybody, the user will be able to change this to any message they want. Let's go ahead and give it a default of on. So this script, this timer will start, the intention is when this script receives the message on, it will start firing another message out to wherever we tell it to go. Let's create another public variable. This one's going to be called timer off message. So when we want to have it stop sending the message to something over and over and over again, it will stop doing that when it receives a message, the message off. Oh, this needs to be in uppercase S. Okay. Another public variable. So here, let's define how often it's going to send that message. Timer frequency, we'll call it. All right. So how often it's going to send this message. We're going to make this a float variable, so it can be a half a second, it can be a whole second, it can be a quarter of a second, not just an integer, which would be just 1, 2, or 3, even numbers like that. We want to make it a really fine amount of time if we so desire. Make it fire really quick. But for default, let's go ahead and set it at 1. What else do we want to have for this guy? Let's have, oh yeah, we need to be able to say what it is, what message is it that we're wanting to send to something else. And that message, we're going to call this one send message to object. So in this variable, we're going to hold the object that we want to send this message to. And this is going to be a game object. And null is a, you notice up here on the top we've set these to different values. Like the string, we set it to a particular kind of string. By default we're setting it to these two characters, ON. Here this is an object that if the user never drags anything into it, this is a special value that we can test against to see if anything has been assigned to this, because we want to look. We want to, for our own purposes, for some error checking, before we try to do anything to this thing, we'll check it to see if it really is set to some other object. If we find null in there, and it's not just the characters like a string, it's not 4 values, it's internal state that just means that there is no, this variable will not actually be pointing at anything. Now we need to, this will be the message that we'll send. Message to send. And this will be a string because our messages are strings. Equals, we'll set it to tick, like a tick of a clock. Tick, 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 tick. Every time this thing, it's going to send the message. Every time the timer fires, it's going to send the message tick. Why not? So now let's create some private variables that we're going to need to use to track what we're doing inside this script. This variable, this first one we're going to call timer on. So is the timer actually timing? Are we in the process of sending messages or not? So to begin with, we're not going to be sending messages. Let's create a variable called timer on, and this is going to be a Boolean type of variable, meaning its state is either on or off. It has no other states. True or false. In this case, we're going to be false, because when this thing very first starts, we don't want it doing anything. We want it to wait until it gets a message. Don't just start firing for no reason. We also want to keep track of, we want this variable here we're going to use for what time to wait for to fire the next message. And we'll talk about that in just a second. So wait until time. So you notice I'm trying to name my variables kind of what they're for and what they do. That's a very good practice to get into. And this is going to be a float variable, and we're going to set it equal to, I might as well set it equal to 0 because we're not, well, we'll be setting it later as well. But I just like setting things to something. To begin with, we don't really need to use this start, I don't believe, for this script yet. So let's leave that alone and move right to the update. So our update, I'm going to start it off with an if statement. So if we're actually doing anything, so if timer on equals true, and the and is the same as you're probably used to for a logical and, it's two ands after each other, and for a logical test of a Boolean value in our if, you use when you're testing to say one variable, if a variable is equal to something else inside an if statement, you use a double equal sign. Whereas other places, it's a single equal is set this to this value. In this case, we're testing this variable against a value, and actually in this set of what I'm showing you right here, it's not intended to be a programming lesson. There are many other places on the internet to get much better, more in-depth how to program. Again, my intention here is to just show you the workflow on how to get your script into Unity and some of the particular quirks of Unity, and how to find the cool things in Unity to get access to with your script. So back to this. If the timer is on, if we're actually timing, if we're actually tracking and trying to send out scripts or trying to send out messages, then as well, we are sending messages, we are doing our timing, and we also want to test to see, is it time yet to send the message? And here is a thing that we can access in the Unity engine. So I typed the class time. This is one of the things we have access to that comes along with the Unity engine. Time dot, and it's a class again with a lot of things inside it, and the dot lets us get access to those things inside the script or inside this class. And what we want access to is just happens to be the word time again. So inside the time class is just the current time. There's lots of other things in here that we can use for other things, like delta time is how much time since the last frame. I'm not going to go through all these. That's just an example of what some of these other things are. And I'll show you where to find what they all mean later. So if we're actually running the timer, if we're sending messages, timer on equals true, and the current time of the game is greater than the time we're waiting for, then let's do something. Okay. And if that is the case, right? So if we're currently timing and the time is greater than whatever time we want to wait for before we do that, then we're going to do this next statement. Now, if both those things are true, now we're going to want to send the message. And here is a cool thing about the Unity editor. It will allow me to complete. It's guessing what I want to type, because I typed enough keystrokes, and send message to object is another function inside Unity that we have access to, and it's going to just, if I hit the space bar, let me try that again. Send a message to object. There we go. Hit the return key and it fills it in for me. Send message to object. And we can send a couple of we can send messages two different ways. To a particular object, or to all the objects up from this object and all the ones above, like all the parents of this particular object. But in this case, we're just going to be simple and send it right to this object, and then not worry anything further about it. We're just going to send it right to that one object. And what is the message? The message, actually what this is. So send message, if I hit the parenthesis here, to begin entering variables into this thing. There's several different types of different groups of messages that we can send, different values that we can send in this message. We're going to use this one right here. Well, we're going to send the method, and what's the name of the method that's going to receive a value, comma, whatever value it is we want to send. In all these scripts that I've created so far, we always send to a function called message, and the message is always a string value. So the name of the function is called message, and the value is that we want to send. Remember, this is what we're sending to the other object. Is stored in this value up here, or this variable up here. Okay. So we're sending to the object that we defined. So here's the object to send it to, and then so on that object we're going to execute the function send message, which again is a built-in Unity function on every object. Every game object has a send message, and then it's going to hunt for the function message and pass to that function this string. And currently, just by default, that's the string it's going to send. This message will contain, this variable will contain this string value. But again, we can totally change that at runtime. That's what the inspector's for. All right. Now, once we've sent that message, we want to update our timer. We want to update the next value to wait for. Otherwise, it's just going to fire over and over and over. So we're going to say, now that we've sent the message, let's update our wait time. So our new wait time, the time to wait for the next time we come through the update loop, is going to be time.time, like whatever time it is right now, plus the frequency that we said that we want to have this operate at, or that we want to, the amount of how often that we want to send the message. In this case, is going to be 1 second. So the time we want to wait for is the time it is now plus how much time to wait before sending the next message. So this was now 1 second into the future. The next time it comes back through this loop, the next frame, it won't, a whole second will not have passed unless our frame rate really, really is terrible. So more than likely, it's going to have to go through this loop a lot, and then eventually a second will go by, and it will send this message again, and then update the wait time for 1 more second into the future. So that's the function. This is the code that gets run every single frame. We still have to do a couple of things before this can happen, right? Because this variable will never, currently by default is equal to false. It's never going to fire. So we need to now enter our functions to wait for that message. And we do that by writing our own new function. The other two functions were created for us. If I could type, it'd be awesome. By Unity, but here's one for ourselves that we're going to create on our own. And just like every other function that receives a message, this function also, this script also has the listening function being called message. And we know that the message coming in is going to be a string, so let's go ahead and set this up as a string. So the message name is going to be a string. Oops, what happened? Oh yeah. It likes to keep an eye on that. It thinks it's part of the same editor is used for C#, and for some reason it keeps liking to have string be the lowercase version of the function that C# uses. Of string. Okay. So whenever a message comes to this script, it's going to be processed by this message function. So we want to listen for two kinds of messages. We want to listen for an on message, and we want to listen for an off message. So whenever this gets run, let's see what kind of message is it that we received. So we're going to test message name to see is message name equal to, copying this and pasting it here, the on message. Oops, this needs to be a double equal. Remember, we're testing the value. So if the message coming in, which is here, is equal to the message we're waiting for to begin firing repeated messages to whatever the destination object is. If we get that message, let's turn it on. Okay, so we'll turn on our variable that tells the update function, go ahead and start doing this. So now this is where we set timer on to equal true. Yes, we're doing it. However, no, that's actually all we need to do. Yeah, we just need to turn that guy on. Okay. And then we want to do the same thing for turning it off. So if, or the opposite for turning it off, if message name, I like to copy and paste in case I get a typo. It's less likely if I copy and paste it, I'm going to spell it wrong. So if the message is, if message named instead equals the string that's in timer off message, in that case we want to set timer on to equal false. Okay? It's pretty much that simple. And that should do it for our script, I think. More than likely there's going to be a bug. I will have done something wrong. But I'm going to save it and let's go see if Unity likes it. So saving it, and then I'm just going to minimize this. We're going to go back to Unity, and I'm going to click on Unity. And as soon as I do that, it then tries to compile the script. And if there's a problem, look down here on the bottom. See this? Ah, there is something I did wrong. So if there's a problem, it's going to show up in this line at the bottom of the Unity window. And to get more information about that, we're currently in this project tab, but see this console tab next to it? Click that, and we're going to get more information about that error. If I click on this error, then let's see, it says unexpected token if. I put an if in the wrong place. Here's something kind of cool. If I double click on this error message, it then opens up the editor and puts the cursor on that. See the cursor's right here? It puts the cursor on the same line as the problem. So here, so if message equals, why is it not expecting? Oh, I forgot to put an opening curly brace. So function needs an opening curly brace, and then it's showing us that now it's balanced correctly. If I click on the first one, it says orange highlighting the last one, or the matching brace. Okay, so now it should be, that problem's been fixed. Let's save it, minimize, and go back to Unity and see if there is any further problems. Okay, so all our messages have gone away. Okay, clear. I'll explain that after a little bit. Okay, so let's go back over here to the project and look at our new script that we just created, or that we just added our functionality into. Let's try it out. All right, so here's the here is the trigger. Go ahead and look a little closer at this. Here's the trigger, and on this trigger is the on collision send message to the cannon. We're gonna want. I'm gonna add this also to this trigger. This function, this script we just created. I'm gonna drag it onto this trigger as well. But instead, what we want is for our send timed message, we want it to be sending the message to the cannon. We want it to be telling the cannon to fire over and over and over. So let's get the message that the cannon is expecting. It's expecting the message fire instead of tick. So we're going to change tick to fire because I copied and pasted it in there. And we want that message to go to the cannon. So I'm going to click and hold on cannon. I'm not going to release, right? I click and I hold, and I drag it into this space here that's expecting the name of an object. Okay, that should be all we need to change for our new script. But now what we want to do is, instead of on collision sending the message to the cannon, we want on collision to send the message to this same object, where on message send where this script will be listening. Okay, so instead of having send message send it to the cannon, we want to. I'm going to click and drag the name of this same object here. So we want on collision send a message to this same object. Okay, the same object that we're on. And instead of sending the word fire when we enter the trigger, we want to send the message on. So I'm going to type on when we enter the trigger. And here, this is the other one we haven't used before. We want, whenever we exit the trigger, let's send the message off. So hopefully what this is going to do, as long as the player is standing within this collision volume, when they enter this collision volume, it's going to one time, as they enter it, it's going to one time send the message on to the same object that we're on, and where the script that we just wrote is going to be listening for either the word on or for the message on or for the message off. And then on collision, when we exit the trigger, as we leave the trigger volume, it then will send the message off to the timer. And at the moment, we are sending or firing once every second. Seems a little slow. We want to be a little more rapid fire than that. Let's say every half second. All right, let's try every half second. All right, moment of truth. I'm going to save the game just because. Let's hit play and see if we got what we want. All right, here I am in the level, getting ready to put my toe on the platform, and we got nothing. Oh, we did get something. Well, this is where the fun part begins. I wonder, we're going to debug what's going on. Interesting. Oh, did I step on and off again? Oh, it's working. I must have stepped off of it before. Anyway, all right. That might mean I need to fire more frequently. Something's feeling a little wanky. Alright, let's go take a look and see if we can figure out what's going on. If we go back over here to console. Okay, so these messages are kind of neat. If you've noticed in some of these before, at the bottom of all the scripts I've created, there's a show log messages. So you can have your script send a message whenever it does something, like whenever it's doing something internally for yourself, like to sort of debug. That's what it's here for. So it will send debug messages that will allow you to kind of get an idea of what's happening inside your game. So I'm going to click this. So in the log, in the console panel here, let's go ahead and clear out all these other messages, and I'm going to turn this guy on for the trigger. So anytime collision happens, it should send a message. It should send us a couple of messages about what's going on inside the trigger. And I'm going to do the same thing for the cannon. Like whenever I'm going to turn on show log messages for the cannon. So now some of its internals, it'll tell us when it received a message and when it processed the message and when it tried to create an object. All right, let's try this again. And I have a sneaky suspicion I kind of know what was going on. All right, let's take a look. See the center of this? And this is some of the kind of debugging things that you're going to have to think about when you run into issues with your own games. See how the center is like right on the edge of this wall? I think what's happening is I put this wall just slightly too close to the center, and that object, or that newly created missile, is getting caught on the edge of that wall now and then. So to test my theory, let's go ahead and turn, again, another cool thing about Unity, I'm just going to uncheck this mesh renderer on the box and also on the barrel. So I'm just disabling those two components. So now we can kind of see, they're gone, so now we can see through it, or they're not gone, they're just disabled, they're just not being rendered. And on the game, I'm going to make sure maximize on play is not checked. Actually, that's not going to matter for this. Let's go ahead and leave that on. So we hit play, and let's go here and stand. Oh, did you see it blink? Let's try that again. Okay, that one worked. I have oh yeah, it's that little blink happening right there. I think what's happening there, link. We're barely seeing a few of them. I think what's happening is they're hitting that wall randomly, off and on. So, all right, so let's turn those back on. And I left this in the video just so you can kind of see some of the things that can happen and how, some of the thought processes maybe for debugging things. I'm going to pull a good ways out because that's a large ball that can get caught on the wall. Okay, so let's try that again. Step on the... Oh, there we go. Okay, so I had the thing creating the sphere way too close to the wall, so a lot of the time it was just exploding as soon as it touched a collider, which the walls have a collider. I removed the collider from the cannon so that way it wouldn't be hitting them. You might actually want to put the collider out here in front, or if you want to have collision on this object, you might put an invisible game object out here that really has your script, so it sort of creates it right at the muzzle of the cannon. But okay, so that script seems to be working. I'm standing on the ramp, and if I decide to get off the ramp, it stops firing at me. So there we go. That's how you create a script in Unity to do something it wasn't doing before. Let's take another look at, now let's take a look at some things, where to find a list of lots of cool things that Unity has for us to play with in our scripts. You find those in the Help pull-down menu right here, scripting reference. Click scripting reference, and it's going to open up a, it's going to take you to an HTML file on your computer that came along with Unity. When Unity installed, see this path, it's actually on your hard drive. When Unity installed, it installed all these awesome scripts, or all this awesome reference on your computer to allow you, or to show you how to use Unity. So since since the very basic thing in Unity, again, the very basic thing is a game object. So we can create an empty game object here. Game object, create an empty one. And if we create an empty one, we notice that the only thing an empty game object has is a transform. So we know, so Unity can tell where it is in the world. Other scripts, if I wanted to remove a script like one of the ones that we created, or even this mesh renderer that came along with from Unity that renders this, I can right click on it and say remove this component. It would get rid of it. But we can't do that for a transform, because that is a very, see, it's grayed out. That is a very basic thing that a game object must have. So we can always count on a transform which contains within it the position, rotation, and scale of the game object. We can always count on a transform existing. We can't always count on other components existing. So a lot of times before it's there, we should test to see if in fact it's there. And you would do that. Let's go ahead and do that real quick for our script, because this is a good way to know how to send a message that shows up in the console. Let's go back to our script we just wrote. Double click on it, start it up again. So right here, we're just expecting, we're just relying that the user sent a message, or set up what object to send this message to, when in fact they might not have, and we should check to see if they did or not. So let's put another if inside of here. I'm going to say if, this is how you test, if send message does not, or if it does not, right, that's, you learned that in your programming class from somewhere else. The asterisk and the equal sign means does not equal null, right? If this variable doesn't contain something, right? If it doesn't point to something, am I saying that right? No, I'm saying it wrong. If it doesn't point at nothing, right? If it's not pointing at nothing, it's a little backwards in your thinking, but it makes sense, right? If it's not pointing at nothing, in other words, it is pointing at something, then we're going to go ahead and send the message. Else, right? And else is something we can do if that's not true. Else, and here's how you send a message to the console. Debug is the name of the class, and then dot what kind of message, what kind of debug message do we want to send. Go down here, we find log, just a regular log, which is standard color. Log errors come in as red, like you saw from the compile error, and log warning comes in as yellow. You want to send it as a warning or as an error? Let's send it as an error, because really our thing cannot do something, cannot do what it was hoping to do if it's not there. So log error, and the message we're going to send is no object for message. Let's see. Let's try and make it a little more clear. So you've noticed that Unity will take our message Oh, I really didn't explain that too well. So here, I'll do it in just a second. Okay. Okay. So you noticed up here, this is what they call camel case. This type of lettering where the beginning of each word is an uppercase letter. And if I'm going to save this, let's go back to Unity. Let's double check the console, and it compiled it. There doesn't seem to be any errors. Cool. So now let's go ahead and look. Oh, it's not on trigger. Okay. So timer on message, timer is lowercase, the on is uppercase, or the O in on is uppercase, the M in message is uppercase, but there's no spaces between the words. But Unity does a nicety thing for us, and if you notice what happened, the first word is capitalized, and then whenever it saw an uppercase letter in the name, it put a space. And there's another or in the variable, it found another uppercase letter, which was at the beginning of message, and it put a space. So it kind of makes it human readable, which is kind of nice, right? It looks better, because you know, a space is not an acceptable character in a variable name, but it's kind of ugly if it looked that same way here in the inspector. So they do the nicety for us. Unity does the nicety for us and makes it look a little more human readable. All right, so let's test out that log error that we just put in there, that log catch, error catch log message. And you notice, so I'm going to remove the canon here as the object to send the message to, so we can test it out. See this little bigger than a period looking thing here at the end? If I click on that, it pops up this dialog and allows me to select from a list of every object in my scene, or if we scroll to the top, it lets me select none. And that's what I want for this right now. I want to take out everything from it. Let's go ahead and test. And in this case, the game, I'm going to uncheck this maximize on play. That way it won't fill the whole screen, and we'll be able to see the messages in the console come up. So hitting play, game is now running. I'm going to step on the edge of the console, or the ramp. Bam, there go our error messages. Every time it tries to fire, it says, I can't. There's nothing. I don't know where to send it. So it's doing its job, right? And then even down here in the bottom. So let's go back, fix it, hold down, drag it in here. I'll click clear, hit play, let's try it again, and then the message we anticipated has come in. But it's not firing. Oh, haha, because it's actually supposed to be canon. Yeah, okay, fine. Canon is where you want to send it, not to ourselves. Doesn't do any good to send it back to ourselves. There's nothing listening over here. Okay. Duh. Alright, going back. Stepping on the ramp. Bam, bam, bam. And there's the messages firing off that it's trying to do its job. And these log messages in these other scripts, you can go check out the other scripts and see what I'm doing with these. You want to really keep them turned off, and they are off by default, because whenever messages get sent to the console, if every single object always sent your debug messages or your to the console while your game is running, always, it would fill this up, and your game would run really, really slow. It takes a lot of time to send these messages, but they're so super useful for trying to figure out what problems are what problems might be in your game that you do want them, but you don't want them always firing, always drawing to the console. So in this case, I turned them off. We were getting nothing going to our console, and we have our game working. Okay, so that's what the messages are all about. But let's go ahead and go back to that our page here. Again, the way you get to the scripts, script reference, help pull down the menu, script reference. What do we want to do? We want to, a very, 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 very useful thing to look at a lot is the base of all objects in Unity, game object. Okay, let's look for game object. We're going to search for game object. The very first thing that pops up is the game object class. We'll click on that. Look at all this awesome stuff. Okay, so whenever we want to, if we were wanting to move an object, again, a game object has this transform, and a transform, its position is defined right here. It transform position X, Y, Z. Let's go back and look. So in the game object definition, here's transform. I click on that, it takes us to a small description of it, but if I can now click this to go take us to the transform class, here's all the curiously cool information that's inside that class. So there's a lot of information. We can just keep digging into all the components. Almost every component can be reached this way. All right. So transform position is what we're looking at. The transform. Now let's look down through here through the variables till we find position. Here's position. Right, I clicked that a little too fast. Here's position. If I click on position, it takes me to where I can learn a little bit more about that part of the transform class. A transform class, the position is defined by a thing called a vector, which has 3 parts to it, and those parts are X, Y, and Z. A very, very cool thing about these docs is almost every single thing under these classes has an example of how to use it. So here, if you were to, in your code, type this in, it would move that the script would move your object to the center of the world, to the 000 part of the world. If you want to, let's go back to the game object again. Remember we were hiding things before? The blink script? The blink script, let's go back and look at Unity. The blink script, remember, turns the mesh renderer on and off. Alright, the mesh renderer, let's go look at the renderer. Here we are. Renderer has an enable and disable. Let's find it. Balance. Oh, here it is. So here's the enable part of the mesh renderer. So let me click on that. Here we have some, again, example code on how the mesh render, how to use this in your code. Another cool thing, if you start playing around with C# instead, this pull down here at the top, I can just click C#, and now it shows me the C# version of the example code. Let's go back and look at JavaScript instead. If you were to type this in, render.enabled equals false, that would turn off as you'll go look. If you go look at the blink code, this is pretty much exactly what it does. Here's some further examples of how to do it a different way. So hopefully that's helpful. That's how you get into Unity. That's a workflow for writing one of your own scripts. And under This Is Your Friend, Scripting Reference, that's where you learn, that's where the references are for what you're going to find on how to access these different components that are inside the Unity engine. Again, hopefully that was helpful. Leave some comments below if you have any questions. I hope you had a good time. Thank you very much for watching this video.